Among parasitic diseases, schistosomiasis ranks second behind malaria in global importance. Schistosomiasis, also known as Bilharzia, infects more than 200 million people in 74 countries. This project continues my decades-long focus on the terrible beauty of waterborne diseases. When seen through a microscope, the pathogens are radiant, minute, beautiful beings, and yet the impact of these aquatic parasites when absorbed or ingested into the human system is enormous. I have worked with scientists, non-governmental organizations, and rural communities around the globe, creating visual research projects, bringing awareness to this and other devastating waterborne diseases. They are largely preventable, so it is important that people learn how to avoid them. Most people who live in poverty-stricken regions do not understand that their activities in and around water are high risk. It is important to learn water can be dangerous. Infestations build up over time, and each exposure adds to the risk of serious consequences. Clean drinking water is paramount. In many countries, a faulty infrastructure makes it difficult to access clean water. There are no easy solutions, but education can at least provide guidelines for how to be safe with water. I use natural materials from the region where I am working. At the old Khalili Bazaar in Cairo, we purchase Egyptian cotton for scrolls. From a spice merchant, we buy indigo, saffron root, and henna that I use as paints. In Ethiopia, at a rural market near the source of the Blue Nile, I buy hand-woven cotton fabrics for scrolls. The art is exhibited internationally in museums, local communities, floated in streams, and even hung on our boat as we sail the Nile. The cast of characters in the Bilharzia life cycle includes the cercariae, adult worms, eggs, mericidium, and the host snail.
Now, we just looked at cercariae under a microscope, and if we follow the life cycle here you can see a cercariae with the typical forked tail. This is what you will encounter when you go into the water. This is a stage that will penetrate your skin. When it penetrates your skin, it migrates to the body and eventually ends up in the veins that drain your intestine. Now, the larvae will develop into adults, which you can see here. There's the skinny one, the darker one here is the female, the lighter, bigger one is the male. They will mate and lay eggs. Those eggs will be released into your veins and flow through your body. And these eggs, if you can see them here, has a hook on them, and this hook enables them to hook onto the intestine and work their way through from the vein to the inside of the intestine, where they will be evacuated with the feces. Now, in very heavy infections or long-term infections, if you can imagine hundreds of thousands of these eggs sweeping through your venous system, not all of them get attached, and sometimes they'll get lodged in the liver. The liver tends to be a place that is a filter for unwanted things in your body. So what happens is your liver will take these eggs and make a very hard cellular matrix around these eggs. Now, if you have a lot of these, what happens is your liver eventually becomes very large and irritated with all these eggs. So it's like cirrhosis. And sometimes too you can get enlargement of the spleen, And that would explain the drawings that you saw on the body of this man here. It is to show the enlarged liver and spleen. And this is fairly typical to see a distended abdomen of someone who has a long-term or very heavy infection. Treated people will not get such an enlarged liver. And so in areas where there is no treatment, or it's expensive, or it's very remote, this is more typical of what you would see. So as I said, the adult worms are in the intestinal veins. The eggs work their way into the intestine and will go out in the feces. Almost immediately when the egg hits the water, this little larvae down here, which we also saw in the microscope, a larva called the Mericidium hatches. And it swims around and looks for a snail to penetrate. Once it finds a snail, it penetrates the snail, and it will undergo asexual reproduction, which means one larvae like this will divide and multiply into thousands and thousands of cercari, which brings us right around back where we started. And so when you're in the water, you're coming into contact with both snails and the larvae that are coming out of the snails.
And the cycle begins again and again. Join us now on a brief journey along the River Nile in Upper and Lower Egypt, in Ethiopia, the source of the Blue Nile, and in Nepal as we investigate the waterborne disease, Bilharzia. People often rely on infected water for drinking, cooking, bathing, irrigation, and boat transportation, all of which provide direct exposure to Bilharzia. A woman with a baby on her back fetches contaminated drinking water. An infected lake is the location for washing clothes and bathing. A farmer delivering horse feed paddles his papyrus boat while sitting for hours in polluted water. On our felucca voyage, water taken directly from the Nile was used for brewing tea, bathing, washing dishes, and cooking. Farmers contract the pathogen while working in irrigated fields, where infected snails release thousands of cercari. Along the Nile, there are two kinds of snails. The isolation and magnification of a single parasite changes both the point of reference and our relationship to this organism. The vector can be beautiful. As invading bacteria, it is potentially deadly. People are aware of mosquitoes, for example, because of direct contact, and they might know to use bed nets, bug sprays, and behavioral changes, such as not going out at dusk and dawn. Snails, on the other hand, are usually thought of as harmless, if we think of them at all. One way to change perception is through art and song. As I travel along rivers, I seek out local musicians, all of whom are open and enthusiastic about composing and singing songs, telling the dangers of Bilharzia in their lakes and streams. From Addis Ababa to Aswan, Cairo to Kathmandu, improvisations are sung in Amharic, Nubian, Arabic, and Nepali. Traditional tunes are played on traditional instruments, but the lyrics tell all who hear to be careful how they use water. The advice from specialists about a few ways to avoid Bilharzia is: do not swim in stagnant, infected, or canal water. Do not drink unclean water. If possible, boil water. Do not bathe in polluted water. Avoid warm or shallow water. Do not walk around the shore of a lake without shoes. Working with local musicians, adapting a message to traditional songs, taking those songs out into the population, is a model which can be used effectively anywhere in the world.
Even today, there are 200 million people in the world, most of them in sub-Saharan Africa, who are afflicted with this particular disease. If you look at some of the ancient mummies from Egypt, you will find evidence that they were infected with this particular parasite. So this remains a very serious disease. Currently, we have only a single means to control the parasite, and that is to treat people with a particular drug that's called praziquantel. And even though the drug today still works very well, one of the things that we're worried about is that the more this particular drug gets used without any alternatives, then it becomes increasingly likely that the worms will develop resistance to this particular drug. And if that happens, then it's not good, because we do not have an alternative therapy readily available to treat this particular infection.
Sometimes naturally produced ingredients are used. In Giza, Egypt, we were shown locally grown medicinal herbs that are thought to assist in the healing of bilharzia.
It's also worth considering that there are related species that, instead of developing in people, have as their final host instead elephants. And it's well known now for both Asian and African elephants that they suffer from schistosome infection. And even though the worms that are responsible are individually very small, maybe this big, it's hard to imagine, but these huge mammals can actually become very heavily infected and can be killed as a consequence of infection. And it's known that in India and Nepal, both, there are cases there where some of the domestic Asian elephants have been killed as a consequence of schistosomiasis. So we have developed a number of molecular markers and techniques for genotyping parasites, for identifying species of parasites that rely heavily on this modern technology. And one of the important things that we try to do is to interface with scientists from developing countries.
In Nepal, we travel from Kathmandu south to Chitwan National Park to research elephants infected with numerous parasites. The two biologists, Prem and Ramesh, with whom we work, are being gifted scarves I created for them with images of the snails they research.
His name is Bikram. It's the Bikram. It was so weakened when we visited last time, but now it looks a little better than the last time. They are making the regular treatment. I think they are giving medicine. Bikram Parsad Hatiya Munga Madarari Syahodala Kaelena
Actually, in animals, we can find out problems of schistosomiasis because they continuously come in contact with waters and other. Actually, I think the human beings who also swim in the polluted water, they may also affected. But I think that human beings who come in contact with water as well as animals, they are equally susceptible to infect the schistosomiasis.
There are many parasites. They are found in elephant as well as in the rhinos. And these are two microscopes sent by Locker, and this microscope is for sorting this elephant dung. These are the freshwater snails from Chittagong, and we are keeping the snails in the water, and we put in clean water, and we observe under microscope our last trips samples from Chittagong. We know the name of the elephant, and we have the number in each elephant dung, so that we can identify which elephant is infected by which kind of parasites.
This stool sample is Bikram Prasad, which is a baby elephant and affected by most of the parasites, and we found lots of parasites in this stool sample. We found some of the cercariae over here, animal schistosome cercariae from that species.
We sorted some eggs from elephant dungs, and
These are the eggs I brought back to the United States to be analyzed. People in many disciplines around the world are working together to help reduce the threat of this disease.
This remains a very serious disease. A big part of what we try to do in the lab is to try to stay current with modern techniques, but then always to be trying to figure out how to apply those techniques to some often very difficult conditions in developing countries where some of these parasites are still very much at large.
These interdisciplinary efforts provide ways to break the cycle of this horrible infection, which is often deadly. Through education, awareness, art, song, scientific discoveries, and by working closely with local communities, it is hoped that schistosomiasis will disappear and there will no longer be a need to sing the Bilharzia Blues.